When we have two terms in the denominator of a fraction, we're going to use something called the conjugate to rationalize it and get rid of the square root that's down there. The conjugate just means take your binomial, the two terms in the denominator, and change the sign in the middle. And so, for example, the conjugate of 7 plus the square root of 2 is going to be 7 minus the square root of 2. Only that sign in the middle has changed. Just like we did in the previous video where we rationalized by multiplying the top and bottom by the same thing, that same rule still applies. So we're going to multiply the top and bottom of this fraction by the same thing, because really that's just a 1, and multiplying by 1 does not change anything. So in the top, I need to take 3 and multiply it by 7 minus the square root of 2. I'm going to need to distribute to do that. 3 times 7 is 21. And then 3 times negative square root of 2 is negative 3 square root of 2. Think of that as like 3 times negative x. We can't really do any multiplication other than write them next to each other multiplied together. So 21 minus 3 square root of 2. For my denominator, I need to multiply these two pieces together. So I have two binomials I'm multiplying together. This is where you're going to need to do FOIL, or what I like to do instead is the box method. So off to the side, let's go ahead and do this multiplication. Now the conjugate part, as long as you're multiplying something by its conjugate, you could use your calculator to do this. Just use parentheses, make sure you type those things in carefully, and the way that conjugates work is we're going to have a lot of stuff cancel out. That's why we chose to multiply by the conjugate. So your calculator will get you the answer without decimals, but it only works if you're doing a conjugate. So feel free to use that to check it, or watch how the box method works to multiply this. So 7 and then square root of 2 is one of my terms, and then 7 minus the square root of 2 is my other term. So write those outside the box. And then I'm going to multiply rows and columns together. So 7 times 7 is 49. 7 times the square root of 2 is just 7 square root of 2. 7 times the negative square root of 2 is negative 7 square root of 2. So hopefully you can see what's about to happen. And then be careful on this last box. A lot of people want to put 0 because they're not sure how this works. Square root of 2 times negative square root of 2. The first thing I say is, well, the answer is going to be negative because it's a negative times a positive. Square root of 2 times square root of 2 is square root of 4. But that's a perfect square. So the negative square root of 4 just simplifies to a regular negative 2. So I'm going to put a regular negative 2. Okay? All the things in the box are getting added together. So what we've hopefully noticed, what's always going to happen with the conjugate is those two terms are going to cancel out. 7 square root of 2 plus negative 7 square root of 2 is 0. So my square root's gone, and all that's left from the box is just 49, and then plus a negative 2, or 49 minus 2, which simplifies to just 47. So that is the bottom then of my fraction. Notice the square root has been moved. It's still in the top, but the square root is no longer in the denominator of the fraction. So there's my simplified answer. A couple things to note and to check for when you're doing other problems. As we've always discussed, check that square root, see if that square root could be simplified. 2 cannot be, so that's fine. The other thing to check for is check all 3 of the non-square root numbers. So check all 3 of those numbers and see if all of those have a greatest common factor. They all have to have it. If 2 of them have it, that's fine, but in order to simplify it, they all need that same number. So in this case, there's nothing that all 3 of those terms have in common besides 1. But if you do notice that all 3 can be divided by something, make sure you do that. So that problem is considered simplified. We're going to use the same idea of the conjugate to simplify this. This problem is only a little more difficult because we do have a binomial on the top as well. So really, we're going to have to use the box method twice to get this problem multiplied all the way through. So we're going to start with the denominator, and we're going to multiply by the conjugate of what's in the bottom. Remember, we can have a square in the top, so having a square in the top is fine. We don't care about that. But looking at the denominator, I'm not allowed to have that square root. So I multiply by the conjugate, which is 3 minus, or square root of 3 minus 2. Same thing goes in the top. Don't try to do the conjugate of the numerator. We don't need to do that. We want to make sure we do the top and bottom by the same thing. So changing that sign in the middle gets us our conjugate. So we have 2 multiplications to do. Now, as I said, the denominator can be done using your calculator. We can type that in a calculator. Something times its conjugate will have all the weird square root stuff cancel out. So we will get a rational number when we do that. So if you want to save time, you can go ahead and multiply that out. But unfortunately for the numerator, the only way to do that, because it's not a conjugate, it's not going to have things cancel out, we're going to need to use the box method or FOIL to multiply that. There's no way around that using the calculator. So let's go ahead and do the box method for the numerator, and then I'll save some time and just use the calculator for the bottom. So in the numerator, I've got a 1 times the square root of 5, and then a square root of 3 times a negative 2. So remember, numbers inside of a square root multiply together, numbers outside do, but we can't mix and match. So 1 times square root of 3 is just 1 square root of 3. Square root of 5 times square root of 3, though, those are both in a square root, so I can multiply those together and say that is the square root of 15. 1 times negative 2 is just negative 2. And finally, negative 2 times square root of 5 is negative 2 square root of 5. All those numbers in there are going to be pulled out of the box and added together. There are no like terms. Like terms, as far as radicals go, would need the same number inside the square root. Since none of them have the same number inside the square root, there are no like terms in there. So my numerator is going to have 4 terms in it, which may look less simplified than the answer, but it's considered simplified because there will be no square root in the bottom. So I'm just going to write those out in order. So 1 square root of 3 plus square root of 15 minus a 2, and then minus 2 square root of 5 is the numerator. Isn't that lovely? And then for the denominator, well, like I said, I'm going to save some time and just use my calculator off to the side here by typing that in with parentheses. If you don't have a calculator or want to do the box method, it's the same idea. I get, when I combine all that stuff, I get a denominator just of negative 1. Again, I did that on my calculator. I can do that with the conjugate part, otherwise use the box method. So there's my simplified answer. I suppose there's one more thing I could do. Since everything's being divided by negative 1, I could go ahead and divide everything by 1. That would just change everything's sign. So I'd have negative 1 square root of 3 minus the square root of 15 plus 2, and then plus 2 square root of 5. So I suppose I could do that as well if I wanted to simplify this maybe one step further.